Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 175. Please turn to page 175. It is the problem number 162 that we're going to work on, and after we finish problem number 162 we're going to go back and take care of 161. I want to take care of 162 first because 162 involved quite a bit of writing on the blackboard which I wanted to do ahead of time. So here's what's going on in 162. I hope the book is in front of you so that you're able to read the problem on your own. It says, during a trip, Francine traveled X% of her total distance, an average speed of 40 miles per hour, and the rest of the distance at an average speed of 60 miles an hour. So we are told that she traveled a certain percentage at 40 miles an hour, the remainder of the trip was covered at 60 miles an hour. The question simply is, what is Francine's average speed over the entire period? Now before we actually do this problem that is in the book here, let's do this one that you see on the blackboard. Here's the question. It's a very simple, very straightforward question. I traveled half my journey. So instead of X percentage, here I'm giving you the percentage. I traveled half my journey at 40 miles an hour and the other half at 60 miles an hour. The question simply is, what was my average speed over the entire journey? Now over the entire journey, just because you travel half your journey at 40 miles an hour and the other half at 60 miles an hour, does not mean that the average speed is simply the average of the two numbers. It does not mean that. We'll find it out in a second. Here's what we're going to do. We're going to pretend that I traveled. Let's think of some number that we can divide nicely by 40 and nicely into 60. How about 120 miles? 120 can be divided by 40 and 120 can be divided even into 60. So let's pretend that I traveled 120 miles. That would mean that I did first 60 miles, which is half the distance, at 40 miles an hour, and the second 60 miles at 60 miles an hour. If I'm going 40 miles an hour, exactly, it means exactly what it says. I'll be traveling 40 miles in an hour. I have to go 60 miles. The first 60 miles will take an hour and a half. First hour, 1 hour for 40 miles, and then another half an hour for the remaining 20 miles. So it will take an hour and a half. And the second 60 miles, if I'm going 60 miles per hour, will take exactly 1 hour. So the average speed over the entire journey would equal to the total amount of distance that we traveled, which is 120 miles, divided by 2.5 hours. 120 miles divided by 2.5 hours, 120 divided by 2.5. Let's get rid of this decimal from the bottom. Let's multiply top and bottom by 10. Multiply top and bottom by 10. Now 2.5 times 10 will become 25 on the bottom. And on the top we'll have 1200. 1200. Let's write 1200 as 12 times 100. The reason we wanted to do that is because if we write 12 times 100, it's much easier to divide 100 into 25. It goes 4 times. And the answer is 12 times 4, or 48 miles per hour. My average speed over the entire period is not the simple average of the 40 and the 60. My average speed turned out to be something less than 50. It turned out to be 48 miles an hour. Why? because of the fact that when I'm going 40 miles an hour for the first half of my journey, I'm going to all the time, whatever time that I spend over the entire journey, I'm going to spend more than half of my time. The majority of my time is going to be spent at 40 miles an hour. Because you see, what people misunderstand and what people misinterpret when they read a question like this, when they read the question like this, they immediately simply add up 40 and a 60 and divide by 2. These people are not paying attention to what is being asked. If the question was, listen carefully, if the question was, if the question were that I traveled an hour at 40 miles an hour and I traveled the second hour at 60 miles an hour, what is the average speed over a 2-hour period? In that case, the answer would be 50 because I'm spending equal amount of time at the two speeds. But here, it's not the allocation of time that is fixed, it's the distance that is fixed. So if I'm going to travel half my journey at 40 miles an hour and other half of my journey at 60 miles an hour, obviously I'm going to spend more than half of my time, majority of my time, at the lower speed, which is going to pull the average down. So the average is no longer 50, it is no longer 50, it turns out to be 48. Now that we understand that concept, the problem that is in the book there can be very easily done. It can be done just like that without any algebra whatsoever. We don't have to, even though it's a fairly complicated algebraic problem, and if you were to try to do that with the algebra, it will take some time. But if you understand this concept that the average speed over the entire period is only 48 miles an hour, it's not 50 miles an hour. So here's what we're going to do. Now we're going to do the problem in the book. Here's what we're going to do. In problem number 62, in problem number 162, we're going to plug in x equal to 50. X equal to 50. And we already know that when x is 50, which is the percentage, now the problem reads, during a trip, Francine traveled 50% of her total distance at 40 miles an hour, the remaining 50% is 60 miles an hour. Exact same thing what we just finished. We already know what the answer is. If x is 50, the answer is 48 miles per hour, the average speed. All we have to do is go through the answer choices. Wherever we see x, replace it with 48. Wherever we see x, replace it with 50. And keep on going until we get our punchline. Our punchline is this. This is the answer. We're looking for 48. So let's get going. Let's see what they give you in the answer choices. In answer choice A, they tell you 180 minus 50 over 2. 180 minus 50, it must have been 180 minus x. It must have been 180 minus x in the answer choice. 180 minus x over 2 because our x is 50. 180 minus 50 is 130, and 130 divided by 2 is not 48. Answer is not A. B says 50 plus 60 over 2. Again, it must have been x plus 60 over 2, which is 110 over 2. 110 over 2 is not 48. Let's look at C. The answer is, it is 300 minus x. 300 minus x over 5, which is 250 over 5, which gives you 50, which is what it has a technical term. In the industry, we have a technical term for this answer. We call it, it's a term of endearment, we call it the sucker's answer. Answer C is the sucker's answer because they sit there and simply take the average of the two speed. It doesn't work that way. We already saw that. Answer is 48, not 50. Let's look at D. In D, they tell us 600 over 115 minus 50, which is 600 over 65. 600 over 65 is not even 10. That's not the answer. We're looking for 48. Let's look at E. E says 12,000 divided by 50 plus 200. So it must have been x plus 200. Let's see what this works out to be. So this is 12,000 divided by 250. 250. I'm going to write our 12,000. I'm going to write the top part 12,000 not as 12,000 but as 12 times 1000, which is still 12,000. Again, because of the same idea what we did here. You see, 2.5 times 10 was 25, and on the top it was 120 times 10. 120 times 10, we could have written it as 1200, but I wrote it as 12 times 100 because it's much easier to divide 100 by 25. Exact same thing is going on. You see the parallel, how similar they are? Is the exact same thing, no difference whatsoever. So again, 1000 divided by 250 is 4, and the exact same thing, 12 times 4 is exactly what we found here. This is the answer. That's it. So this is the more of an unconventional way, the unorthodox way, unclassical way, non-classical way rather, of doing the problem without the algebra. Just by mere understanding of the fact that if you were to plug in 50 for x and pretend that you're going half your distance is 40 miles an hour and the other half is 60 miles an hour, the average works out to be 48. That's it, we're done with this problem. What I'm going to do tomorrow, if you insist, and only if you insist, we're going to do this problem the proper way, the classical way, the traditional way, the orthodox way, the geeky way, the nerdy way, the academic way, the algebraic way. Only if you are hell-bent. But we'll do that tomorrow. Because doing it the proper way, the algebraic way, is a sheer waste of time in the exam. Don't do that. It will take you too much time, it costs too much, that's all. You have to find an efficient, quick and dirty way to get the answer. Getting the right answer is not enough. You must do it in an efficient manner, which means taking the least amount of time possible and still getting it right. This is it. Let's do the next problem, which is problem number 161 is what I want to do. Problem number 161. Let's see what they tell us in 161. If you would excuse me just for about 2 seconds, I'm still here. I just need to... Alright, problem number 161, see what they tell us there. In problem 161 is a very straightforward question, which is why I left it until the end. Question simply is, what is the distance? What is the distance RS? And here is how what the picture looks like. We are told that this is V. We are told that this distance from V to R is 10. We are told that V to the bottom is 5. This distance from here to here we are told is X. And then we have another distance from here to here, which we are told is Y. This is R. And the total distance at the bottom we are told is 10. So 10 equals x plus y. This is what is given to us, and the question simply is how much is y. It's very straightforward, very simple, as we said. In triangle V, let's call this thing O for origin, VOR. In the triangle VOR, this is our hypotenuse 10. So 10 squared equals 5 squared plus x squared. And from there, of course, we can figure out the x. And as soon as we have the x, we put it in here and find out the y. The question is, how much is y? The distance R to S. This is your S right here. That's what we're looking for. We're looking for what is the value of y. So x squared would be 100 minus 25, which is 75, which can be written as 3 times 25, and therefore x is going to be the square root of it. The square root of 25 is 5, so it's 5 times root 3, and therefore your y is simply 10 minus 5 times root 3, which is answer choice A. And that's all it is. So like I said, number 161 was a straightforward questions. Tomorrow, on day number 179, today was our lesson number 177. Tomorrow, on day number 179, we're going to redo question number 162 in the classical way, but I'm warning you right now, it is going to be nasty. It is not something you want to play with in the real exam. I will talk to you. I will see you tomorrow. Okay? Bye now.